All right, so now we're going to, in 14.3, estimate square roots. Well, what's that? All right, so you need this list, and you hopefully have memorized it. The answers here are perfect squares. That's that list I asked you to memorize. Square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4. Oh my goodness, they're in order, yes. But you need this list to do today's lesson. So please do the whole thing. All right, so 169 is 13, 196 is 14. I'm stopping at the 15. Now, this is the ones inside the parentheses, right? This is not list. 1, 4, 9, 16, 25. Those are called perfect squares. Well, what about the square root of 2? What's the square root of 2? What about the square root of 27? All right. Now, hopefully you understand that the square root of 27 must be between 5 and 6. It's some decimal between 5 and 6. And that's what we're going to focus on today. And it turns out square root of 27 and the square root of 2 are irrational numbers. And what's an irrational number? A number that goes on forever. It's a decimal that goes on forever. Okay. Right, so we know the square root of 1 is 1, and we know the square root of 4 is 2. The answer to those two are both between 1 and 2. They are 1 point something, okay? And the square root of 2 is closer to 1, and the square root of 3 is closer to 2. Hopefully that makes sense. Square root of 9 is 3. So the answer to all four of those are between 2 and 3. There are 2 point something, some decimal. It turns out, and the square root of 5 is closer to 2, and the square root of 8 is closer to 3, and so on. All right, and we're going to see that today. All right, so first we got to make sure we know there are 3 kinds of decimals. There's terminating decimals that end, as in the Terminator in the movies ended people's lives, or the last station on a railroad is called the terminal. It's a word that means the end. Repeating decimals don't just repeat a little bit. They repeat forever. And we show that with either a bar on top or 3 dots. Oops. You establish the pattern, then you show the 3 dots. And now the third type are irrational numbers. They're decimals, and they go on forever just like repeating decimals, but they don't have any repeating pattern. Okay, they don't end and they don't repeat. They don't terminate or repeat. All right, so 0.5, also known as 5/10, is normal decimal, and those are called terminating decimals. They end. There's the end of it right there, right at the end of 5. This, we see those 3 dots, this is a repeating decimal. Repeating decimals can be written that way, or I just showed, or with this little bar on the top of it to show that 5 repeats. But you can have more complicated patterns like 1, 2, 1, 2, 1, 2, like that, and that also is a repeating decimal. This thing is called an irrational decimal or irrational number, and you should recognize that this is pi, all right? And pi, no E on the end, is the most famous irrational number. Pi, right? No one knows the last digits of pi. There's computers still running the digits of pi. It goes on forever, and there's no pattern to it, right? That's why we can't write it with a little bar on top, like 0.5 repeating. It turns out the square root of 2 and the square root of 27 are like pi. They're irrational. Now, IR is one of those prefixes that means not, like on and in and non. So when you say irrational, you're saying not rational. These other two are rational. Irrational numbers are not rational. They are, in fact, we'll find out. Okay, so I've shown a couple of examples of the square root of 5. So I took a calculator out, and my calculator only had that many digits, and then it ran out of space, okay? And so luckily I know the square root of 5 is irrational, because not every calculator will tell you that they just run out of space and stop. And they often round this last digit there, so that might actually not be right. And so the square root of 5 is approximately that. The square root of 23 is approximately that. All right, and we're going to find this out, which is not a perfect square. So the square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. We don't know the square root of 5 except that it's right there. And so 5 is not a perfect square. So when I ask you to do the square root of 5, you're going to estimate it. And that's why this is called estimating square roots. And we're going to estimate mostly, eventually, to the nearest tenth. And we would say square root of 5 is approximately 2.2. Now let's remember our rounding. We'll go over this in a second. Right? If it's 5 or higher, this 2 would go up to a 3, the next digit over. But since it's a 4 or lower, it stays approximately 2.2. All right, so which one's not a perfect square? Hopefully you see the square root of 23, because we know the square root of 16 is 4. We know the square root of 25 is 5. The square root of 36 is 6. Now, notice, this is literally impossible if you didn't memorize the perfect square list, as I've asked you to do in the last 2 lessons. So the square root of 23, it turns out, is approximately, I'm using an approximate symbol, right? We would round that to approximately 4.8, right? Because if we're going to the nearest tenth, which is what we're going to do later, okay? So that's a 9, and that's approximately, so the 7 goes up to 8, and it's approximately 4.8. Now notice, this is approximately 4.8. It's between 4 and 5. It's closer to 5, okay? And why is that? Because 23 is closer to 25 than 16. This one was square root of 5 was, right, the square root of 5. This one is approximately 2.2, right? The square root of 4 is 2. Square root of 9 is 3. It's between 2 and 3. It's closer to that one. And we'll teach you how to do that. All right, which one's not the perfect square? Hopefully you see that one, square root of 49 is 7, square root of 64 is 8, square root of 66, I don't know, square root of 81 is 9. We know the square root of 66 is between 8 and 9 somewhere. It's a number that goes on forever. Every whole number that is not on the perfect square list has an irrational square root. Right, which one's not a perfect square? Square root of that. Square root of 108. Square root of 100 is 10. Square root of 121 is 11. Square root of 144 is 12. So this square root of 108 is between, right, 10 and 11. It's some decimal, 10 point something that goes on forever. This square root of 66 is 8 point something that goes on forever because it's between 8 and 9. All right, so that's what we're going to do. So the positive square root of 7 falls between what two numbers? So 7 is right there. So this is how I want you to do your homework. Square root of 7. Below it, you put the square root of 4. You put the ones from this list. You have to have this list memorized. I'm putting it up there now, but you have on the test, you have to have it memorized. And so on this screen, we're just going to realize that the square root of 7 is between 2 and 3. It's not between 4 and 9. It's between those square roots. Right? But you have to do these square roots. Now the answer to this kind of screen is always going to be 2 and 3, 7 and 8, 2 numbers in a row. Okay? Now I will get out a calculator and tell you the square root of 7. And the square root of 7 is, my calculator says the square root of 7 equals 2.645751311, and then it goes on forever. Right? Well, it's around 2.6. It's between 2 and 3. So you write the square root of 19. Now you look for the list. What's on either side of it? Right there. So it's the square root of 16 and the square root of 25. But the answer to this, the positive square root of 19 falls between what two whole numbers? The whole numbers, and you have to write the words between, because people start thinking the answer is 4 and 5. No, the answer is between 4 and 5. Please write the word between. All right, it's actually, we'll find out later in the period. All right, so we're going to keep doing this. So square root of 41, right, is between the square root of 36 and square root of 49. So on a number line, it's between 6 and 7. So on a number line, it's there. Now, as we keep going, we're going to estimate this more closely. Now let's look at 41. 41 is 8 numbers away, right, from 49. 49 minus 41 is 8. 41 is 5 numbers away from 36. So what does that tell us? And by the way, this is 6 and 7. That was sloppy. it tells us that the square root of 41 is a little closer to 6, the low end, than the high end. Now let's remember, what's right in the middle? What decimal is right in the middle? 6.5, right? And we have to know 6.5 is equal to 6.5. So now, what we know is we now know that we've narrowed it down. So this is it could be 6.1 approximately, it could be 6.2, it could be 6.3, or it could be 6.4. It's one of those approximately, because it's between 6 and 7, and it's closer to 6. All right. Since it's closer to 6, it can't be 6.5 or 6.6 or 6.7, anything higher than 6.5. Okay. Let's try this again. All right, so square root of 67 is between square root of 64, square root of 81. So it's between 8 and 9. So it's over here. Okay. So let's see that, between 8 and 9. Now this time, look at this. 67 is just a little bit more than 64, and it's what, 14. It's way, all right. What does that tell us? Well, it's way closer to 8. So it's more likely, really it's 8.1 or 8.2. It can't be anything else because it's really close to 8. It's near that end. Okay, square root of 65, square root of 66, I bet, are both round to 8.1. Okay, because of rounding, one could be slightly lower than 8.1, one could be higher. I haven't checked it, but that's what logical. Okay. So this one, you could really narrow it down to 4. And think about this. This is not, right, the square root of 37 is probably 6.1. So that one's probably not 6.1. Okay. All right, let's do one more. Square root of 103. Okay, so we said, so let's say, by the way, so we know the square root of 67 on the number line would be somewhere right around there, a little more than 8, right? And the square root of, I'm going back to 41, is right about there. It's lower than 6.5, but not right up against 6. All right, square root of 103, well, that's between the square root of 100 and the square root of 121, which is between 10 and 11. Now this is only 3 away from 100, and it's what, 18 away from 121. So again, the square root of 103 is really close to 10. All right, it's probably 10.1 approximately. Okay. And so that's what we're going to be doing. All right, so let's see what this falls between. Now let's understand. We have 169. Now that's 13. Now even if you don't know the next square root, remember if it's 13 there, it has to be between 13 and 14. All right, it can't be 13 and any other number. Truthfully, you only have to know one side, right? If you knew this one was 196 and got 14, then this side has to be 13. All right, it's between two whole numbers that are right in a row, like 13 and 14, 5 and 6. Okay. All right, so like I know that's 225 is right above that 15. Oh, and this is 196 again. All right, so this one is between 14 and 15. But notice the square root of 224 has got to be either 4.9 or it might actually round up to 15. It's so close. All right, because 224, right, either is approximately 15 or approximately 4.9. This one, 170, is a square root of 170, either rounds to 13 or it rounds to 13.1, right? Because these are both way at the end of the space in between. All right, so now we're going to round it to the nearest whole number. So that's what I just did. Square root of 27 is the square root of 25 and the square root of 36. So which one is it closer to? Is it closer to 5 or closer to 6? Well, it's only 2 away there, and it's 9 away there. So the square root of 27 is approximately 5. Is it a little bigger than 5? Yes. Is it an irrational number that goes on forever? Yes, but the square root of 27 on a number line is a little bigger than 5. That's where it would go. So it says round to the nearest whole number. Whole numbers are like 0, 1, 2, 3, 4, 5. Square root of 61. So the square root of 61, 64 is right above it. 49 is below it. So this is 3 away. This is what, 12 away. All right, so it's much closer to 64. So the square root of 61 is approximately 8, right? Because you have to do between 7 and 8, right? And so on a number line, the square root of 64, right, the square root of 63, 62 would be right next to 8. It's right about there, okay? That's where you'd put square root of 61 on a number line. A little less than the square root of 64, 8. Okay, let's practice. Which is not a perfect square? That one. Square root of 16 is 4. Square root of 9 is 3. Square root of 1 is 1. Square root of 15 is not a perfect square. It's 3.9 or 3.8 approximately, right? Because it's a little less than 4. Which is not a perfect square? 48, right? Square root of 49 is 7. This is 8. Square root of 36 is 6. And notice the square root of 48 is got to be approximately 6.9 or 7. All right, so what does it fall between? It falls between the square root of 1 and the square root of 4. Now, every year I do this problem and I get people to tell me the answer is 1 and 4. No, it's between 1 and 2 on a number line. 1 and 2 on a number line, right? The answer always is the square roots. All right, so this is between the square root of 25 and the square root of 26, so it's between 5 and 6 on a number line. This is between, well, 121 is right above it. Oh, 100 is below it. So this is between 10 and 11 on a number line. And notice it's almost 11, 10.9 approximately. All right, nearest whole number. So square root of 45 is between the square root of 36 and the square root of 49. So it's between 6 and 7 on a number line, but we want to know which one it's closer to. What's the nearest whole number? Well, that's 9 away. That's 4. It's closer to 7. So we would say the square root of 45. Don't use an equal sign because it's not equal to that. It's equal to approximately 7. That's the nearest whole number. And final question. So 400 is right below it. So that's 20. Now, I don't know the next perfect square, but I know since that's 20 that this must be 21. Now, if you wanted to know what it was, right, it is 441. But you don't have to know that. All you have to know is that square root of 407 on a number line is between 20 and 21. Good luck with the homework.